one or two more problem for center of mass. So let us try to go for a semicircular disk. This is also one of the favorite question for your examination. And this is something like this is in X direction and this will be in Y direction. And you can just assume this is symmetric about X and Y. So this is my center and the radius is R. So mass is M. So what we have to do? We have to calculate the position of center of mass. So again, I can say, what will be my XCM?
0.
0.
0.
Because the mass is symmetric about y-axis. So XCM is 0. What we have to calculate? We have to calculate YCM. So what will be YCM? So that value is equal to Y dm upon dm. So this is my YCM. And if you are going to calculate this particular YCM, which coordinate system is the best coordinate system to solve this particular problem? Obviously, circular polar.
Yes,
So we can take some elemental mass, something like this. This is my elemental mass. Okay, this one at the angle theta. And this is nothing but what? D theta. So we can write m upon pi r square by 2 is equal to dm upon r dr d theta, isn't it? And what is your y? Your y is equal to r sine theta, isn't it? In a circular polar coordinate. So we will just try to go for it. And this can be, and if when you are going to calculate this particular thing, what will happen? This mass is m because this is constant. So we can directly write this particular thing. So let's try to go for it. So y is equal to r sine theta r dr d theta, and we have to go for double integral. And here, and obviously we can write this particular thing m upon or 2m upon pi r square. And if you are going to integrate it, this is nothing but what? Mass m. And what is going to happen? This is 2m upon pi r square. That value is r square dr. And this is going to 0 to capital R. And again, we have to go for sine theta d theta. And you will go for this thing is what? 0 to pi. And this m will be always there. So everything is okay. So this m is cancel out. And what you will get? Sine theta d theta 0 to pi. What will be integration? That will be 2, isn't it?
Yes,
Hoga
sir.
na? That value is 2. And what is this value? So you have 2m upon pi r square. And this value is equal to r cube by 4 by 3 into 2, isn't it? So, and by m is also there. So we can remove this particular m. So we have 4r upon 3 pi. One of the favorite question for GATE examination or IIT-JAM examination. This is one of the favorite one. So at least once and 2 times they have asked this particular question. And this is one of the important question for NAT. So they will just write, you have to just calculate the value of 4 upon 3 pi and you can easily give the answer. Everyone is comfortable?
So theta will vary from 0 to pi.
Obviously, theta will vary from 0 to pi.
So
What is
why
your
not
opinion about theta?
pi by 2?
Why? Why
Sir,
pi by 2?
because x से y pi by 2 या तो रिवॉल्व करके वो सिमेट्री से बन.
नो मैं समझ नहीं रहा हूं. अगर आप इस सेमी सर्कुलर डिस्क में जा रहे हो तो थीटा को जब तक पाई तक नहीं ले जाओगे तो क्या सेमी सर्कुलर डिस्क मिलेगा क्या?
नो सर.
अगर आप समझ गए?
यस सर.
हाँ, this is agar if you are going for 2 pi, then you have complete circle and you will get center of mass here. Are you getting my point?
Yes, sir. Yes,
जैसे
sir.
इसको 0 to 2 pi करोगे ये 0 हो जाएगा, है ना?
Yes, sir. Yes, sir.
हाँ. So why you have to just see agar if I am talking about center of mass about this particular thing, this area, then you have to go for 0 to pi by 2, isn't it?
Yes, sir.
है ना? So ये चीज दिमाग में रखोगे. Okay, let's try to go for some 3-dimensional picture also. कुछ 3-dimensional को देखने की कोशिश करते हैं. Let's try to go for it. And these questions are directly come into your exam, है ना? Directly, so you can remember, or you can also remember this some results. So let's try to go for this is all about your hemisphere. So this is your x, sorry, this is your x, this is your y, and this is your z. Okay, so here you have to give the coordinate of center of mass, and this is hemisphere, and this is, we can assume this is solid hemisphere. The mass is m, the radius is r. So what will be your xcm?
0.
X dm upon dm. And why xcm is 0?
Due to symmetry.
Because you can see the whole hemisphere, if you will see this part, x and y part, and this is your z part. So x and y part has complete circle, isn't it?
Yes, sir.
And then you can easily say, otherwise you can calculate also. You can calculate also. Why it is 0, we will discuss it. And what is your dm? Dm upon 4 pi r cube upon 3, sorry, dm upon this will be r square sine theta dr d theta d phi. This is your volume element, and this will be equal to m upon 4 pi r cube by 3. So what is going to happen? This value is 3m upon 4 pi r cube. So what is your dm?
By 2 भी होगा ना volume.
By 2 भी होगा. Very good. So that will be 2 here. So this will be 6. है ना? Good. So we can easily calculate value of dm. And what is your x? X की value क्या होगी? R sin theta cos phi. So when you will go for r sin theta cos phi, so we can directly use it. And now look at here. What will happen for first term? That is r square dr 0 to capital R. And here you have sin theta here, sin theta here. So you have what? Sin square theta d theta 0 to what? What is value of theta?
0 to pi by
Pi by 2. Theta is just 0 to pi by 2, isn't it?
yes, sir.
So this value is equal to pi by 2. And what about cos phi? And what about phi part? Cos phi d phi. What is this part?
0 to 2 pi.
0 to 2 pi, exactly. And why it is 0? Because cos phi d phi 0 to 2 pi is 0, isn't it?
Yes, sir.
This is not 0 due to this term. This is not 0 due to this term. This is 0 due to this term. So what will happen when you will see the whole hemisphere from downward? You have to go for complete circular plane, isn't it? So why xcm is equal to 0? What will be ycm? What will be ycm? What is change?
0.
What will change into ycm?
So
By
the-
d phi.
Huh?
Sin phi d phi.
That y. So you
that will be
for
sin
if
pi
you
d-
are writing for ycm, then what will happen? This will be y dm upon dm. And what is y here? Y is equal to, you can again go r sin theta Sine phi. And again, if you will go for this particular integration, the first term will be remain same, second term will be remain same. The first term will be r into r square dr, 0 to capital R. Second term will be obviously sine square theta d theta 0 to pi by 2. What about third term? Third term is equal to sine phi d phi 0 to 2 pi, and this term is also 0, isn't it?
Yes, sir.
है ना? जैसा cos phi 0 to 2 pi में behave करेगा, वैसा ही sin phi 0 to 2 pi में behave करेगा. So hence, and you can see we are just talking about this particular planar arrangement of mass on a plane, on a xy plane, and then we will go for z axis. Is that z will be also 0? Xz will be also 0?
No, sir.
No. When your xz will be 0, when you will have this kind of situation. Are you getting my point? Look at what will happen when we will go for ZCM. That value is integration ZDM by dm. Obviously, we have to integrate it. And what is your Z? Z is nothing but r cos theta, isn't it? So what will happen? So Z is equal to r cos theta. And when we will go for writing each and everything, so ZCM is equal to 6m upon 4 pi r cube. This term is there. You have r into r square dr, 0 to capital R. And what about your theta part? Cos theta. This is this cos theta. Sin theta. D theta. 0 to pi by 2. And what about next one? D phi 0 to 2 pi. Yes?
Yes, sir.
Now, you can easily calculate this particular thing. What will happen? So that is your ZCM is equal to 6m upon 4 pi r cube into 1 upon m. This is this m. We have to divide it by m here. Into what will be integration of this one?
R to the power 4 pi.
R to the power 4 by 4. What about this integration? Phi part will be something like 2 pi. And what will be this integration? Cos theta, sin theta, d theta. We can put cos theta is equal to t. Then sin theta, d theta is what?
dt.
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 And we have to go from what? 0 to 1?
Yes, sir.
Isn't it? So what will be this value?
1 by 2.
1 by 2. So this value is equal to nothing but what? 1 by 2. देखो तो क्या आंसर आ रहा है? I think ZCM will be, so 2 pi is 2, 3. I think this will be 3 by 8r.
Yes, sir.
Isn't it? This is very famous question. This is very famous question. So this is 3 by 8r. So somewhere at this point, you have this particular moment of, this particular center of mass. So this type of question will always come into your exam. And now you can do it for this quadrant also. But always try to use your coordinate transformation very efficiently. आप जितना ज्यादा efficiently coordinate transformation का यूज करोगे, उतना बेटर आप चीजों को कर पाओगे. Let's try to go for one very interesting question where you will cut the sum portion of mass, and then how you will go for finding the center of mass. And yes, we will use something like as a negative mass concept here. So we will just try to figure it out. Let's see what will happen. यहाँ तक clear है ना? Everyone?
Yes, sir.
कोई डाउट है तो आप डाउट पूछ सकते हो. चलो.
सर हॉलो हेमिस्फीयर में हम एरिया एलिमेंट लेंगे ना?
बिल्कुल एरिया एलिमेंट लेंगे क्योंकि मास जो है वो सरफेस पे होगा, है ना?
यस सर.
और उसमें r की वैल्यू फिक्स होगी, है ना, बिकॉज r इज फिक्स।
यस सर।
ओके, सो आप ट्राई करो उसको करने का, ठीक है। सो नाउ लेट्स ट्राई टू गो फॉर अ वन वेरी इंटरेस्टिंग प्रॉब्लम। कुछ एक ऐसा प्रॉब्लम है, एंड लुक एट द लैंग्वेज ऑफ प्रॉब्लम इज वेरी इंटरेस्टिंग। दिस हैज मास m, इसका मास m है, और वी आर जस्ट गोइंग टू, एंड आई कैन से दिस इज माई x axis, okay, and this is my y axis. So this is a some circular disk is there, and what we are going to do, we are just going to remove a some portion of disk with a radius a by 2. So this will be a by 2. इसको आप रिमूव कर रहे हो, एंड दिस विल बी रिमेनिंग देयर, ये यहां बच रहा है। ओके, एंड नाउ वी हैव टू कैलकुलेट द सेंटर ऑफ मास। हम लोग अब इसका सेंटर ऑफ मास निकालने की कोशिश कर रहे हैं। आर यू गेटिंग माई पॉइंट एवरीवन?
Yes.
इनिशियली इट्स मास इज m, m मास है, उसके बाद आप इसे निकाल रहे हो। आर यू गेटिंग दिस प्रॉब्लम? ये कंबाइंड सिस्टम का मास m नहीं है। एवरीवन इज कंफर्टेबल?
Yes, sir.
A disk of
Now
mass
calculate.
m, in the disk of mass m, we just remove the portion of radius a by 2, and then we have to calculate what is center of mass. So what we will do, we will assume there is two mass. Suppose one is circular disk, and there is two circular disk. You can assume something like this. Okay. So what will be center of mass? Where is the center of mass of this particular disk?
At the origin.
At the origin. Okay. Okay. So this will be at the origin. And where is center of mass of this particular disk? At the origin.
No. A by 2.
अगर इसका लेंगे या सेपरेटली लेंगे तो क्या होगा?
Yes, sir.
इसके origin.
That will be at the origin. Okay. Now ये concept को आपको ध्यान में रखना है. So we have, I can assume its mass is m and its mass is m1. Okay. And here this is my origin O. Then what will be this distance? A by 2. Yes या no? ये जो डिस्टेंस कितना है? सपोज दिस इज ऑरिजिन, पूरे कंबाइंड सिस्टम का सेंटर ऑफ मास कहां पर होगा? एट दिस पर्टिकुलर सेंटर। एंड इसका सेंटर ऑफ मास कहां होगा? एट द सेंटर ऑफ दिस वन। एग्रीड और नॉट?
Yes, sir.
What I am trying to say, if this has radius a, where is center of mass of this particular system? At the center. And if it has radius a by 2, where is the center of mass? At this center. It is different issue that this coordinate is have different, this center has different coordinate with respect to this one. Are you getting my point or not?
Yes, sir.
So I can assume this mass, this as a point mass whose value is m, and I can assume this as a point mass whose value is m1. So what will be the combined center of mass? xcm, m1 into 0, sorry, m into 0, this is my 0, 0 coordinate, plus m1, and what will be this coordinate?
A by 2.
A by 2 by m plus m1. Everyone is comfortable?
Yes, sir.
Now, what is value of m1? So you can write m upon pi a square is equal to m1 upon pi a by 2 whole square. Yes or no? So what is m1? So m1 is equal to m by 4. Yes, but this is a hollow part, so we can assume the mass is removed from there, so we can put m1 is equal to nothing but minus m by 4. लिख सकते हैं इसे,
Yes, sir.
है ना? And now you can put it into this particular equation. Then what will happen? This value is equal to m into 0 plus minus m by 4 into a by 2, and here is m plus minus m by 4. So what will be this value? क्या आ रहा है?
minus 3a by 2.
कितना आ रहा है? So minus a by
6.
8 by ये कितना आ रहा है?
minus a by 6.
3 by 4, है ना? So this will be minus a by 6. So where is your center of mass actually? And what about YCM? What about YCM? बताइए क्या होगा? m into 0 plus m1 into 0, because this is not going to shift here, isn't it? ये कुछ इस तरह से किया हुआ है कि this is along the x-axis, जिसको इसी को हम कॉमन सेंटर को ही x-axis मान रहे हैं. So this value is equal to obviously 0. So this value is equal to 0. So where is your center of mass actually?
So it is minus a by 6.
It is in negative side. So here is your center of mass, and it is very logical also. Why it is logical also? Because more mass distribution is towards the left of the axis of y-axis, and about x-axis the mass distribution is symmetrical, isn't it?
Yes, sir.
आप देख रहे हो, अगर इसको आप देख रहे हो पूरे पिक्चर को, तो they have making the exact shape about the x-axis, but they are not making exact shape about the y-axis, isn't it? If you will put the mirror, you will get exactly same thing. But if you are put mirror at this point, you will not get exactly same thing, and hence you can find this is your particular moment of inertia. Sorry, this will be your basically center of mass. So this concept is very interesting. You can use the point mass concept or two separate body, and then you can find the combined center of mass of the system. So we have just keep this thing separate. We have just keep this thing separate, and then with respect to this thing, we have assumed there is just one point mass, there is another point mass, and we can find the center of mass. And negative sign is because we are taking out of this particular mass. But listen, language is very important. The mass m is the mass of complete disk, and out of that we are removing some portion of mass. So then only we can use this concept. Otherwise, it will be very difficult. Okay, then you have to see how this mass is varying. Okay, clear है यहाँ तक?
Yes.
Yes, sir.
Okay.
Excuse me, sir.
हाँ बताओ.
सर एक बार माइनस साइन फिर से एक्सप्लेन कर दीजिए जो
माइनस साइन में बोल रहा हूं कि इसमें से मास निकाला गया है. आर यू गेटिंग माय पॉइंट? यहां से मास को हमने निकाला है, हटाया है. इफ यू विल रिमूव मास, then obviously the mass will be negative. So we can take the concept of negative mass.
ओके सर.
भाई पहले इसका मास m था, अब कुछ पोर्शन का मास निकाल दिया, तो मास तो घटेगा ही ना.
यस सर.
तो वही चीज को हम यहाँ पर यूज कर रहे हैं. ओके, सो दिस मास इज -1.
Sir,
Hmm.
I have one doubt, sir.
Yes.
Sir, original disk का center
Mhm.
of mass at origin,
Sorry.
center of mass at origin, ना sir?
Listen. Original disk का center of mass at origin. Yes, there is origin.
Yes. And removable part का
का सेंटर ऑफ मास, द सेंटर ऑफ, लिसन, आप ओरिजिन मत बोलो, आप कुछ ऐसे बोलो, फॉर द ओरिजिनल डिस्क द सेंटर ऑफ मास इज सेंटर ऑफ द डिस्क. आर यू एग्रीड?
Yes, sir.
So this is the center of the disk, this is the
Yes.
center of disk.
Yes, sir.
Okay,
Yes, sir.
for the removing disk the center of mass is at the center of removing disk. Okay,
Yes, sir.
yes, so this is the center of removing disk. Okay,
Yes, sir.
so what will be mass of at the center of, and what is the coordinate of the center of original disk is 0 0.
Yes, sir.
What is the coordinate of center of removing disk? A by 2 0.
Me too.
Okay,
Yes, sir.
so we have written 0 and A by 2.
Yes,
Agreed?
Sir. Yes, sir. Got
We
it,
assume the total mass m is here. Agreed?
Sir. Yes, sir.
And we assume the total mass here is m1.
M1.
And but hence we are removing this particular mass. So why I have taken this thing as
Yes.
negative sign.
Yes, sir.
So then you can put it all this thing.
Thank you, sir.
Okay. So this type of problem will come into your exam, and you have to be conceptually ready that how you can use the negative mass. We will do some more problem of this particular negative mass and all this thing into moment of inertia also. But let's try to go for what is moment of inertia and how your parallel axis and perpendicular axis theorem can be used here. ठीक है? So इसको हम लोग करने की कोशिश करते हैं. Yes.
सर एक और डाउट था, वो
बोलो.
हम मास निकाल रहे हैं तो m माइनस समथिंग हो जाएगा ना?
नहीं.
हम माइनस m कैसे लिख सकते हैं?
क्या बोल रहे हो?
सर ओरिजिनल डिस्क का मास m है ना?
ओरिजिनल डिस्क का मास m है. हाँ.
सर उसमें हम एक बार निकाल रहे हैं तो m माइनस समथिंग.
यहाँ देख लो m minus m1 if m1 is equal to minus m by 4. नहीं.
सर हम उसको माइनस m कैसे लिख सकते हैं?
मतलब आप एक तरफ बोल रहे हो ओरिजिनल मास को हम निकाल रहे हैं तो m minus m1 होगा, तो यहां भी तो वही है. m1 की वैल्यू क्या है? minus m by 4. Are you getting my point?
नो सर.
What is this thing? This thing. Now you are comfortable?
यस सर.
Huh?
हाँ सर.
So I am writing the same thing, na? If I am going to write this thing as minus m1, then what will be the problem?
ओके सर समझ में.
Because listen, what I am saying, if you are removing the mass from the original body, you can assume that mass as a negative mass, and I am using the same concept of center of mass, same formula of center of mass, that is from the plus sign. Are you getting my point?
यस सर अभी समझ में.
हाँ. Okay, so let's try to go for a sum problem. Or first we will discuss the basic of what is moment of inertia. If I am talking about moment of inertia, that is exactly same thing of the diagonal term of the moment of inertia tensor. Are you getting my point? Okay. So now, what is moment of inertia? So I am just using a very basic definition. Suppose this is some distribution of mass and which has mass dm. And what I just want to calculate the moment of inertia about some axis. Let's say this is A and A dash. So what is moment of inertia about A dash? This is suppose moment of inertia. This is nothing but integration of dm into r square. And what is this r? this will be perpendicular distance from the axis. This R is perpendicular distance from DM to this particular axis. Are you getting my point? R is actually perpendicular distance of DM, perpendicular distance between DM and axis. So it is a very basic thing that you can use in each and every problem. So you have to always go for perpendicular distance. Okay? You have to always go for what is your perpendicular distance. But if you are going to solve all the problem from this method, you can solve it. Theoretically, you can solve it, but it will take a lot of time. So we can use two different theorems that will help us to solve the problem very quickly. That is only for the efficiency. Otherwise, you can solve each and every problem from this particular method. Each and every problem. If somehow you know how your mass is distributed, so you can find the DM, and then you can calculate the perpendicular distance with somehow you can, if you are able to calculate the perpendicular distance with the axis, then you can easily calculate one. But we will use two basic theorem. The first theorem is parallel axis theorem. This is very famous. Parallel axis theorem. What is this parallel axis theorem? So suppose I have any mass distribution you have, and somehow you know the moment of inertia about the axis which is passing through center of mass. So how many axes can pass through center of mass?
Infinitely many.
Infinite number of axes. Okay. Suppose I know this as my axis, and this is your center of mass. Okay. And this is my axis which is passing through center of mass. So this will be ICM. You can have axis also, this is passing through center of mass. You can have also this is passing through center of mass. And if I want to calculate the moment of inertia about axis A dash. Okay. If we are just going to calculate the moment of inertia about A dash, just A dash, and this D is the perpendicular distance between ICM, so about this axis which is passing through center of mass, and this particular axis which is parallel to this one. Are you getting my point? Suppose your axis is passing something like this, then you can use the parallel axis theorem if it is parallel to this one. Everyone is comfortable here? है ना? ये दो एक्सिस अगर एक दूसरे के पैरेलल होंगे, then only you can use this one. And this distance is again, you can say this is your D. And D is nothing but the perpendicular distance between two parallel axes. One axis is going through center of mass. So why center of mass is very important? So what will be, and let's say this is again some axis, let's say A dash. You can have something like this. If you know the moment of inertia about this axis and another axis is parallel to this one, then you can use the parallel axis theorem, and that value is equal to I A dash must be equal to ICM plus MT square. What will be this value? ICM plus MD square. What is this mass M? Mass at center of mass. Okay.
Yes, sir.
And what is this D?
Perpendicular distance from the
Between
between the axis.
Between axis which is passing through center of mass and the axis which is parallel to that particular center of mass. Okay, so this is very famous and very efficient theorem where you can use this particular parallel axis theorem. Okay, and this is used for 2-dimension, 3-dimension, all kind of mass distribution. So it is a general theory. Okay, 1D, 2D, 3D, you can just go for this thing. And second is perpendicular axis theorem. Second is what? Perpendicular axis theorem. So what will be your perpendicular axis theorem? The perpendicular axis theorem, if you have distribution of mass and you have your mass distributed into x-axis and y-axis, and this is mainly used for plane. This is not for 3-dimensional. Okay, so this is mainly used for plane. So this is x-axis, this is y-axis, and you can assume origin is at the center of mass. In general, we will choose origin is at the center of mass. Okay, then we can find Iz is equal to Ix plus Iy. So somehow we know what will be moment of inertia about x-axis, what will be moment of inertia about y-axis, and then I can say Iz is equal to Ix plus Iy. Where masses are distributed? In xy plane. So we can get this particular perpendicular thing. And you have seen this thing into your moment of inertia tensor also. है ना?
Yes, sir.
जब भी हम लोगों को xy प्लेन में मासेस डिस्ट्रीब्यूटेड था तो जेड के निकालने की जरूरत नहीं होती थी, isn't it? Because both are just connecting with your perpendicular axis theorem. So आज सपोज करो कि yz में अगर आपका मास का डिस्ट्रीब्यूशन है तो क्या होगा perpendicular axis theorem?
Ix is equal to
Iy plus Iz. So you have to always be careful that in which direction you have distribution of mass. Oh, sorry, in which plane you have distribution of mass. So mainly this is for the 2D plane. और 1D plane भी कर सकते हो, but 1D में कोई खास यूज नहीं होगा इसका, because but in the 2D plane you can use it very efficiently. यहाँ तक clear है everyone?
Yes, sir.
Okay, so let's try to solve one basic problem, and in the next class tomorrow we will finish this particular chapter. Okay, and इसका यूज होगा आपका रोटेशनल डायनामिक्स में, जो कि हम लोग नेक्स्ट वीक में इसको फिनिश करेंगे. ठीक है, देखो what is going to happen. Suppose this is your disk, sorry disk नहीं, this is your linear mass distribution rod मान लो, है ना, and we have to calculate the moment of inertia about this particular edge, one edge. So you can easily calculate this thing. Calculate कर सकते हैं ना,
Yes, sir.
है ना, क्या होगा इसके about? So x, so first we will use the first principle. We will just go for what? dm, and at which distance? X distance, and mass distribution is between linear, so we can take dx. Okay, so suppose either this axis or this axis, is that perpendicular axis is perpendicular distance is same?
Yes, sir.
Okay, so let's say this is Iyy, y dash. Okay, so Iyy dash. What will happen? Something square into dm. What is this something square? Perpendicular distance. So this will be x square into dm. And what is your dm here? बताइए.
M upon
by
L
L
into
into
dx.
dx.
M by L into dx. So you can take m, and here you have x square dx, and you will integrate from here to here
0 to L.
0 to L, and m by L is there. So what will be this value?
ml square by 3.
ml square by 3. Straightforward, we can use this thing for a direct first principle. Now we can use it with the parallel axis theorem. We can also use it. So when we will use the parallel axis theorem, then what will happen? Suppose we have, so first what we have to do, we have to calculate ICM, isn't it? And where is the center of mass for this particular rod?
L by 2.
At
L
the
by 2.
center.
So what we will do, we will assume this is at the center. Very good. This is the good answer. And we assume this is my origin. Okay. The center of mass, we will take origin. So what will be ICM? So we just want to calculate the moment of inertia about this axis. So I will take again dx, dm. And what will be perpendicular distance? Let's say this distance is x. So we have to go for x square dm, and we have to integrate from where to where now?
Minus L by 2.
Minus L by 2 to plus L by 2. And what will be dm? Dm will be again m by L. You have x square dx minus L by 2 to plus L by 2. And I think you will get ml square by 12. Yes?
Yes, sir.
So you will get ml square by 12. Now we can use the parallel axis theorem. So we have calculated the moment of inertia about center of mass. And now we just want to calculate the moment of inertia about this particular point. So let's say this point is y dash. So what will be y dash? What will be y dash?
ml square by 3.
So that value is equal to ICM plus MD square, isn't it? Now, what is ICM? We have calculated ICM. So that is ml square by 12 plus m. What is your d here?
L by 2.
L by 2. You can just go for L by 2 and you will get exactly same thing, ml square by 12, isn't it?
ml square by
Sorry, ml square by 3. Sorry. So this will be ml square by 3. Exactly same thing you are getting here. Agreed?
Yes, sir.
Now, the beautiful part is that in general, the more or less, अब इसी कारण आपको दिमाग में यह आना चाहिए that in any textbook, they will give the moment of inertia about center of mass, isn't it? ताकि एक बार अगर आपको सेंटर ऑफ मास के अबाउट मोमेंट ऑफ इनर्शिया पता है तो आप इजीली पैरेलल एक्सिस और परपेंडिकुलर एक्सिस थ्योरम का यूज करके फटाफट मोमेंट ऑफ इनर्शिया निकाल सकते हो, है या नहीं?
Yes, sir.
Yes. So you can easily calculate the moment of inertia. So, but before using this particular moment of inertia about any particular axis by using perpendicular axis or perpendicular axis theorem or parallel axis theorem, before that you have to calculate moment of inertia about the axis which is passing through center of mass. And one particular axis will be very significant because your mass distribution is very much symmetric about this axis. Are you getting my point?
Yes, sir.
So we will try to do different type of problem into next class, mainly tomorrow's class, and we will finish all this thing. Clear है ये?
Yes, sir.
So आज के लिए इतना ही रहने देते हैं. So tomorrow we will finish this particular chapter. ठीक है? And then we will go for in the next week, most probably we will go for what? Rotational dynamics. It will take 2 classes or 3 classes. In one class, we will discuss mainly momentum, angular momentum and energy. And another classes, we will discuss torque and all this kind of topic. Okay. So any doubt you have?
Sir,
Hmm.
how we take the limits minus L by d2 plus L by d2, sir?
Because we have chosen origin at center of mass.
Yes,
Okay.
sir.
And where is center of mass? At the center of rod, isn't it?
Yes, sir.
If it is center of rod, and if we are saying it is 0, 0 coordinate, then this coordinate is minus L by 2 and this coordinate is L by 2,
Yes, sir.
isn't it?
Yeah.
Okay.
Thank
So
you,
the choice of origin is very important, isn't it?
Yes, sir.
And in general, if you are using this particular thing, this concept of parallel axis or perpendicular axis, in general, we will choose a center of mass as our origin, which I have discussed into last class also. है ना?
Yes, sir.
ओके, तो आज के लिए इतना ही रहने देते हैं, कल इसे कंप्लीट करेंगे, ठीक है?
Thank you, sir.
थैंक यू.
Thank you, sir.
Thank you.